Welcome to my new YouTube channel. Today I am going to explain interference of amplitude. Quantum mechanics is all about probability. We assign amplitude to any event. Suppose there is a quantum event, we assign amplitude phi or alpha or theta, and when we square this amplitude we will get probability. So square of the amplitude is probability of certain event. Suppose we are conducting an experiment. In this experiment there is a alpha particles. And we are using alpha particles to bombard oxygen molecules. In that kind of event there is a interference of amplitude. Suppose in this experiment we are using center of mass system as reference frame. Center of mass system as a reference frame. And in this experiment there is a alpha particle, and in the center of mass, if we use center of mass as a reference frame, then before the collision the direction of alpha particle and direction of oxygen atom in the opposite direction. It means they are traveling in the opposite direction. After collision they are also traveling in the opposite direction, and we are making two assumptions. Assumption 1, that there is low energy collision, so that alpha particles or oxygen molecules doesn't break apart. Second, that energy is conserved. Suppose this is the alpha particle and this is alpha particle, this is oxygen molecules, and we have placed two detectors, detector D1 and detector D2. These two detectors can detect alpha particle or oxygen molecules after collision. This is the detector D2, and this one angle is theta. So when we bombard alpha particle on oxygen molecules, then that event will have certain amplitude. Suppose the angle between these two alpha particles and oxygen molecules is theta, and suppose amplitude is f theta, then what will be the probability? Simply probability will be f theta whole square. After that alpha particle either can reach at detector D1 or at D2. Same way oxygen molecules can be detected at D1 or D2. and we can arrange this experiment in another way. In this way, this is theta and this is pi minus theta. D1, D2, this is alpha particle, this is oxygen molecules, and in this one the angle between these two events is pi minus theta. In that case, what will be the amplitude? Simply f pi minus theta. If angle is pi minus theta, if angle is theta, then amplitude is f theta and probability is f theta whole square. Then we can ask, what is the probability of getting some particle, either alpha particle or oxygen molecules at detector D1? What will be the probability? Then the probability will be getting any kind of molecules, any kind of particle at only detector D1 is probability of getting any particle at D1 is f theta. We can add probability f theta whole square plus f pi minus theta whole square. This is the probability of getting any kind of particle only at detector D1. Then the second question will be, what if we only want alpha particle at detector D1, only alpha particle? Then we have two conditions, or we have two kind of arrangement to get alpha particle at detector D1. At one arrangement the angle is theta, and in the second arrangement the angle is pi minus theta. In that case we have to add the amplitude, then square the whole thing. It means the probability of getting alpha particle at detector D1 is f theta plus f pi minus theta whole square. In that condition, what we have taken is the two kind of arrangement to get alpha particle at detector D1. In one arrangement the alpha particle is at angle theta, and in another arrangement the alpha particle is at angle pi minus theta. So f theta is the probability amplitude of getting alpha particle at D1, and f pi minus theta is the probability amplitude of getting alpha particle at detector D1. So f theta plus f pi minus theta whole square. This is the probability amplitude of getting alpha particle at D1, and this upper thing is getting any kind of particle at detector D1, and same thing can be applied for getting particles at D2 or getting any specific particles at D2. Suppose theta is pi by 2, then f theta is simply f pi minus theta. That in that case getting a probability of getting alpha particle at D1 is f theta plus f pi minus theta whole square. In that case f pi by 2 pi by 2 whole square, or 4 f pi by 2 square. This is the probability of getting alpha particle at detector D1 when angle between these two alpha particle and oxygen molecules is pi by 2. Suppose instead of using alpha particle and oxygen molecules, we are using electrons, identical electrons. So this is electron and this one is electron. This one is also an electron. Then what will be the probability of getting electron at D1, detector D1? Then in that case there is a negative interference of amplitude. So simply we have to exchange sign. It means instead of f theta plus f pi minus theta whole square, we can use f theta minus f pi by theta whole square. This is the probability amplitude. This is the probability of getting electron, at detector D1, f theta minus f pi by pi minus theta whole square at detector D1, because these two are identical particle. It means when they collide there will be negative interference of their amplitude. Due to this we have to use negative sign, f theta minus f pi minus theta whole square, because there can be two kind of arrangement for this type of collision. In one event electron at angle theta, in another event electron is at angle pi minus theta. Now electron also have spin. So electron also have spin. Suppose this electron has up spin and this electron too has up spin, or this electron has up spin or down spin. So in that case there can be different kind of probability of getting a electron at D1 or electron getting D1. It means there can be many kind of probability. In one case both particle has up spin, in another case both particle has down spin, in one case up or down, again down or up. So we can make a table of probability of different kind of event of getting getting electron at detector D1. So we can make table. Here is the different kind of arrangement of collision between two electrons. In this one both electron has spin up, so we can arrange such a way that the angle between these two is theta. Again we can arrange such a way that angle between these two is pi minus theta. Theta. Again another case where alpha particle has electron has up spin and this electron has down spin. D1 detector, D2 detector electron. Again another arrangement, angle between these two is theta. Here f pi minus theta, E D1 D2. So these are the four kind of arrangement of electron collision and four kind of spin, spin up or spin down. So what will be the probability of getting electron at detector D1? Suppose particle 1 has, this is one particle, this is second particle, this is another second particle, one particle and second particle, first particle and second particle. So suppose both particle has spin up and when we detect electron at D1 it has same spin up, and when we detect another electron at D2 it also has spin up. Then what will be the probability of getting electron at detector D1 or D2 is f theta minus f pi minus theta whole square. Simple. This is spin 1, this is spin 2, this is at D1, this is at D2. Suppose spin 1 of first particle, spin of the first particle is down, again second particle is down, electron at D1 is down and same is D2. It means there is no change in spin after the collision. Then what will be the probability? Same, f theta minus f pi minus theta whole square. So in case when spin was unchanged before and after the collision, then the probability of getting certain particle at D1 or D2 is f theta minus f pi minus theta whole square. Suppose electron 1 has spin up, electron 2 has spin down, and suppose at D1 spin has changed. So at D1 we are getting spin down, and in D2 we are getting spin up. Again in D1 we are getting spin up and down. It means getting electron at D1 is spin of electron at D1 is down and spin of electron at D2 is up. There is a change of spin after the collision because the particle 1, electron 1 has spin up, after that it has become down, and this is the first case. In second case there is no change between the spin of the electron before the collision was up, after that it was also up. So down up or up down. So what will be the probability of getting certain particle? In that case, if there is no change in spin, then we can say that f theta square. If there is no change of spin after the collision, if there is an interchange after the collision, then f pi minus theta whole square. This is the probability of getting electron at detector D1, and this one was the first case, this one was the second case, this one is the third case. Fourth one is electron 1 has spin down and it has spin up, and at D1 we are getting spin up and down. Again in second case we are getting spin down for the D1 detector and up for the D2 detector. Then what will be the probability in that case? F pi minus theta when spin was changed, f theta when there was no change in spin. So these are the probability of getting certain spin at D1. So these are the 5 probability of getting particle of different spin. So total probability is the half of all this probability. So we can add all this probability and divide by 2. That one will be the total probability of getting electron at D1.